Okay, in this example, we're going to get into the naming of really the simplest of the ionic compounds. These are binary ionic compounds, metal with a nonmetal. Remember, the metals are the cations, positively charged. The nonmetals are the anions, negatively charged. We combine cations with anions in order to have neutral combinations, meaning the same amount of positive charge as we have negative charge. So in this example, we have to write the empirical formula, just like we did in the previous video, and we're going to go one more step, and we're going to name the compound. So here's the idea. Naming binary ionic compounds. Fill in the name and empirical formula for each ionic compound that could be formed from the ions in this table. So let's take a look at the first one. There's a barium, Ba plus 2, and an oxide, oxygen, 2 negative. Let's do the formula first. Remember what we said, the positive, they're going to combine in small numbers so that the positive charge is equal to the negative charge. Well, these charges are equal, right? Positive 2 has the same amount as negative 2 does. So that means they're going to combine in a 1-to-1 ratio. You're just going to have one barium and one oxide. Now, naming the binary ionic compounds, very simple. You name the metal, barium. You name the anion, the nonmetal, but change the ending to IDE. So it becomes oxide, barium oxide. There's no numbers indicated in here. You may have heard prefixes in your life, mono, di, tri, all that sort of thing. Not for these types of compounds. If you have a metal, and the metal is in the first two columns, you just name the metal. Then you name the nonmetal and you change the ending to IDE. Doesn't matter how many ions there are in the formula, we just name using the system. Second one, barium plus 2, again. Remember, barium is in the second column, so it's plus 2. Phosphorus has a charge of negative 3 because it's in column 5A. Now take a look at this. We can't combine it 1 to 2 or 2 to 1. And the reason is that if we had 2 bariums, that would give us plus 4. That's more than the minus 3. So one way to do this is a little trick. I don't particularly like it, but you'll see it all throughout textbooks and such. If the charges are 2 and 3, just flip them. Whatever the charge is here, make that the subscript for this one. And whatever the charge is up here, make that the subscript for this one. That works with the 2 and 3 combinations. So Ba 3 P2. How does that work? Well, barium's plus 2. So you have plus 2. You have 3 of them, though. Right? So that's plus 6. And then the phosphorus is minus 3, but you have 2 of them. That's minus 6. So plus 6 minus 6. It works. Naming it, pretty straightforward. Barium. Name the metal. Name the nonmetal, change it to IDE. So it's not phosphoride, in the sense you might think it would be, but it's phosphide. I guess one way to think about it is the anion generally only has 2 consonants, or I'm sorry, 2 syllables, I guess is the word. 2 syllables, sorry. Phosphide, nitride, oxide, bromide. Generally, that's true, not always. So the next one is barium with sulfur. So barium and sulfur. Barium sulfide, right? So that's easy. But keep in mind, plus 2 minus 2, the charges are equal. So it's just going to be 1-to-1 ratio. If the charges are equal, it's a 1-to-1 ratio. So 1 barium, 1 sulfide. Name of it, barium sulfide. Change the ending to IDE. Last one, barium with nitrogen. Barium 2. Remember, nitrogen is in the column 5A. So when you have 2 and 3, you could just do the little switching trick. So you get Ba3, so there's your 3, and then N, oops, and then a 2. There we go. So Ba3N2. So barium nitride. Now this is how it works with the metals that are not transition metals. With transition metals, we sometimes have to use Roman numerals, but that's not this exercise right here. This exercise is dealing with a group 2 metal.